Okay, what's up, guys? This is Akshay here, and let us continue with the next question of our bit manipulation playlist. The next question is the counting bits. So let us see what the question says, and you can think of the different possible approaches. So, given integer n, return an array of length n plus 1 such that for each I 0 to less than equals to 1, uh, answer of I is the number of ones in the binary representation of I, right? So, what this question practically is saying is that you have one sec that what we have for n equals to 5, you need to maintain an array of from 0 1 2 3 4 and 5, and you need to return the count of set bit. So for 0 you can clearly see it's 0, for 1 the number of set bit is 1, and similarly for 2 it is 1 again, for 3 the number of set bits is 2, the 4 number of set bits is 1, for 5 number of set bit is 2, right? And that is your resultant array, right? So what would be your first approach? First approach is just do as the whatever question says, and that would be your brute force, right? So method 1 will take you n log n as time complexity and O of 1 as space complexity. So what is the approach? It says that you calculate the count of set bits for each and every number. So this calculating count of set bit itself will take you log n, right? And that is why the overall would be n log n. What is method 2? Method 2 would be O of n as the time, and the O of n, O of 1, not n, O of 1 as space complexity, right? So prerequisite about this is, or you should know count set bits, then you will be able to do brute force, right shift and left shift. So let's say when I say 101 is the binary representation of 5. Now when I say you that right shift by 1, right shift by 1, then what it basically means is that you need to say 5 is equals to 5 by 2, which is nothing but 2. Or in the binary representation it says that remove your first bit, right, since it's 1. If I would have said 101 right shift 2, then definitely remove your two bits and you have 1 here. And in the decimal representation also it would be 1, right? So what we will do here is that we will make a array 0 1 2 3 4 and 5, and we will initialize the first, because we know the number of set bits in 0 would be 0, right? So what we will do is, let's say for example 5101, I will just calculate that what is my last bit, is it set or not. And how I can do, I can just do an AND operator with 1. So since these all bits are 0, then the resultant would be 0, and since this bit is 1, I will get the I will reframe the exact bit set or unset in the given number. So here it is set, I will say 1, right? And for this thing is nothing but 5 by 2 is equals to 2. So when I will be at this fifth position, definitely this 2 would be calculated, right? So I will just say my answer of I is nothing but I and 1. Calculate my first bit and then utilize your linear array I by 2. That is it. So for 1, what will happen? So first of all, the dry run would be like 1 and 1, 1 and 1, plus the answer of 1 by 2, that is 0. So 1 and 1 will give you 1, and here it will be, so the final answer would be 1 here. Similarly for 2, what will happen? I will do 2 and 1 plus answer of 2 by 2 is nothing but 1, right? So 2 and 1 will give you the resultant of 0 0, right? So 0 plus answer of 1 is 1. Similarly the answer would be 1, and similarly it will happen for 3 4 and 5, and you'll get your answer as 2 1 2. Now feel free to dry run for rest of the cases which I have not shown you. And yeah, that's the method 2. Let us see the code now. So that's the method 1 we have talked about, that we will have an answer initialize array, and then we will have a for loop, and for each and every number we'll call a function that is count set bits. Count set bit is nothing but we'll have a while loop, and then again we'll count the last position is set or not, and then again we'll right shift it by one position, that is n equals to 1 by 2, and then again we'll keep on counting it, right? Yeah, so that would be your brute force technique. I will not show you the run of this code. Yep, but feel free to try the brute force approach, right? So that's your second approach. So you'll have an answer array, and then the number of set bit in 0 definitely is 0, so that's what we have initialized it initially. And then we have a for loop going for I equals to 1 to less than equals to n, and then we have the final expression, that is calculate for the just last set bit, and for rest of the bits you take the privilege from your initialized array. And also this thing is also known as dynamic programming, that repeating sub problems, once we have find the repeating sub problems, we'll use it. So what is the time and space complexity for this code? Definitely we are just using one for loop, so it would be O of n. And what is the space complexity? O of 1. Great. So that's the summation we have in Java. Let us switch back to C++ code. So here the return type is vector. So we'll initialize the vector and everything remains same as we have seen in Java and Dryden. Great. So that question is also accepted. Solution. Okay, few last thing, that's my DSL repository. Whenever I submit a code, it goes in this repository. It has more than, I don't know, more than 300 questions here on the standard ones. You can take help of the source code from here. And what else? If you understood the problem and the solution, do like, share, and subscribe. Till then, let us meet again in the next video. Till then, keep learning, keep growing. Bye bye, and take care.